Come here, I will continue. If there's a 3, so in that case you can either divide that direction or you can divide that direction. So these are some possibilities that you can have. You can divide. So based on these possibilities you can identify the asymptotes. So let's do an example here and try to solve without doing calculation. So there's another point, that is root locus on real axis. So this you must know, this is very important. So on real axis the main idea is that if you plot your what I say poles and zeros, so the main idea is that, for example, you have pole here, zero here, and pole here. Though on real axis the main idea is if you are here you have to look in this direction. If there's only pole, if there is any pole or zero, if there's no pole, so this means that there will be no root locus till next pole come. When you come here you will move and look in that direction, there's only single pole, means that number of poles and zero sum is odd, so there must be some root locus till the next zero or pole. After that you again come here and look again, this number is even, so there's no root locus exist on the left side. Again you move here. So this is the basic idea, and we know that at pole value of k equals to 0, at 0 value of k equal to infinity, at pole value of k equal to 0. So we know that the k always start from poles and end at 0. So this is the direction, and again it is start from here, it must be end at infinity. So this is the basic simple example where you can use the real axis information to draw the Rootlocus. Now let's do another example a bit more complicated, and then we will sketch it with freehand. I say freehand means that simple sketching. After that we can calculate the exact location. So first step is draw S plan. So this is my S plan. On S plan just look at the pole and 0. So 0 is at -3, pole is at 0. So this is the first pole origin, second one is -1, third one at -2, then at -3 you have a 0 here, and you have a pole at -4. So this is the basic idea, that we just plot the poles and zeros. Okay, this is my j omega, this is my sigma. Okay, so this is my S plan. Now the first thing that we can do, that we know that the value of k here is 0, here again k is 0, here again k is 0, here again k is infinity, here again k equal to 0. So this is the first information we know. Now these are known as open loop poles. Now when we plug in the values of k, these pole moves. Now question is how we get this value, k is 0, k is infinity. So it's very simple. I just do a little maths here. Assume that you have k g of s h of s. If you remember, plus 1 is equal to 0. This is a non-characteristic equation, and we start from here, that k h of s is equal to -1, if you remember. Okay, now for this one we are looking for this side, and we assume that this is equal to some numerator and some denominator. Okay, so this is the basic idea, and assume that this is equal to -1. Okay, now to calculate the poles and zeros we have to get some values here. Okay, assume that in first case k is equal to 0. So when k is equal to 0, this implies that, just do a little maths here, k n of s equal to d of s with minus sign. When k is 0, so this implies that d of s is equal to 0. So this gives you the poles of the system. So that's why for k equal to 0, we have poles. Similarly, for second bit, k equal to infinity. So for infinity, we know that infinity can be written as 1 by 0 times n of s equal to minus d of s. Alright, so do the cross multiplication, it becomes n of s is equal to 0. So this gives you the zeros. So this is the basic mathematics where we know that these values 0, infinity, and so on. Now the next thing is root locus on the real axis. So from another thing, before starting this, we have to count the number of poles and zeros. How many poles? 1, 2, 3, 4. So this means that n is equal to 4. Number of 0, 1, so m is equal to 1. So we must know the difference, n minus m equal to 3. So there are three zeros that are missing, and that must be at the um, infinity. Now we don't know at which direction infinity. So how we do that? We know that we have this circle. I told you we can divide this into three parts. Either we can do that, or we can do that. Okay, these are few possibilities. There are other as well, but we just consider these two possibilities still. Okay, now the question is which one we have to choose. For that, we have to draw the real axis root locus. So as we are here and we are looking this direction, there is no pole and 0 even number, so there must be no root locus. Now here, when we reach here and we look here, only one pole, so this means that root locus must be exist till the next pole or 0 will appear. So there must be root locus between this. So these will be always start from the pole. So that's why I put direction on both sides. Now after that, the number is again even, so there must no root locus on this location. Again I come here, there will be a root locus, so this will start from here and finish at the 0. Okay, now again come here, 1 2 3 4, no root locus. Again there's a root locus, and this will start here and goes to infinity. Now look here, this represents going to infinity, this represents going to infinity. Okay, so this means that this I will select because it is already going infinity in this direction. So now question is where I put this number to show the asymptote. So this is a little calculation I need. Now how I made this calculation, very simple. I just look at the location of poles. I put here pole is 0 at, then I put the location pole is -1, then location of pole is -2, then -4. I just add all these and put minus sign here. Again look at the location of 0, real location, and this is -3, and then divide by n minus m. Okay, now it becomes -7 and plus -7 plus 3 divided by 3, so it becomes -4 by 3, so it becomes -1.3 something there. So there must be point somewhere here. So this is known as sigma, that give us the location where I have to plot, where I have to draw these angles. Now this is the one angle. Now if I write a line here, so I know that how can I divide 360 into 3 equal parts. So this becomes 120 degree each. So this means that this angle is 120, this angle is 120. Okay, this angle is 120. So the main idea in asymptote is to divide the 360 So if there's a 3 difference, so it means that every angle must be of 120 each. So for 120 I have to plot this angle as a 60 degree, this is also 60, so this is the line. So I have to plot something like this and make this angle of a 60 degree. Again, something like this. These are my asymptotes. Again, this angle must be 60 degrees. So 60 become 120. So this is already 120 degree. And this is already 120 degree. So this is the way I can plot the asymptote. So this is asymptotes, not the root locus. So we know that this will going somewhere from here. To find this point, we call it a breakout point because it is going away. But I'm not telling you how to do it right now, but what we mean that one branch root locus start from this pole and goes in this direction along this asymptotes. Now the second branch comes from here and goes in this direction along the asymptotes, and so one is going in this direction. So this is 1 0, this is second 0 at infinity, this is third 0 at infinity. So this is my whole plot of root locus. I easily plotted without doing much calculations. Okay, so now the things left with us is how we calculate this point exactly from where it will goes, and secondly at which angle it will goes, and thirdly where it will cross this j omega axis. So we can find this crossing. How we find it? If you remember, we study the Routs criteria. So Routs criteria help us to find out the crossing of j omega axis. Okay, so how we find the Routs criteria? So if you remember, for Routs criteria we need characteristic equation that is equal to 1 plus k times s plus 3 whole divided by s into s plus 1, s plus 2 and s plus 4 is equal to 0. So this is the characteristic equation. So from here we will use this characteristic equation and to apply the Routs criteria to find the j omega axis crossing. Okay, now how we do that? Very simple. So if I rewrite on next page, and I can say that assume we have because of simplification it becomes s into s plus 1, s plus 2 into s plus 5 plus k times s plus 3 is equal to 0. So we need to solve this using Routs criteria. So after doing a little mathematics, we come up this polynomial, and we use this polynomial using Routs table to find the value of k where it will cross this j omega axis. Okay, to find this point. Now we do that very simple. Just make a table here. We say s4, s3. Okay. Now for s4 is 1, then the 14, then the 3k. Now for s cube is 7, then we have a plus k, and we have 0. Now for s square. So we can use this Routs table and we easily find out the values of this crossing j omega axis. Okay, so this is the way we can solve or sketch the root locus easily. Okay, I will stop here and we will continue next example in next video. Thank you.